Hello and welcome to this recorded refresher session of handling data at level 1 and 2 for NCFE Legacy Functional Skills Maths. My name is Charmaine Phelps and I am the Curriculum Officer for Maths Functional Skills here at NCFE. The purpose of this session is to review the subject content for handling data at level 1 and 2 of the Legacy Functional Skills Maths qualifications. We're going to take a look at the following content in this session. The Department for Education subject content statements for the Legacy Functional Skills qualifications, probability, mean, median and mode, range, graphs and charts, and then end with a short summary. So at level 1, the subject content for handling data, learners need to be able to extract and interpret information from tables, diagrams, charts and graphs, collect and record discrete data and organize and represent information in different ways, find mean and range, and use data to assess the likelihood of an outcome. At level 2, learners need to be able to collect and represent discrete and continuous data using ICT where appropriate, use and interpret statistical measures, tables, and diagrams for discrete and continuous data using ICT where appropriate, use statistical methods to investigate situations, and use probability to assess the likelihood of an outcome. First, we'll take a look at probability. Probability is a mathematical term that you use to show the chance of an event occurring. This means that you're stating numerically what the chance is of something happening. If you flip a coin, it could either land with heads up or the tails up. There are only two possible outcomes from tossing the coins. It will either land with heads up or with tails up. So you could say that your chance of getting a heads is an even chance, as there is a 1 in 2 chance of getting heads. This can be written as a fraction, so it would be a half, as a decimal, 0.5, as a percentage, it's a 50% probability. Or you could mark it on a probability scale. So 0.5 is marked there in the middle on this probability scale. As another example, the probability of throwing a 6 on a dice, there are 6 possible outcomes from throwing a dice. When you throw a dice, it's either going to land on 1, 2, 3, 4, 5, or 6. You could say that it's unlikely that you'd throw a 6 first time, as there is only a 1 in 6 chance of throwing a 6. Again, this outcome can be expressed as a fraction, so it's a sixth, as a decimal, 0.167, as a percentage, 16.7%, or you can mark it on a probability scale. It would be marked about here on this probability scale, 0.67. You can also compare possible outcomes using probability, as in this example. So, is it more likely that the first card Dan deals is red, or that it is a picture card? It's worth making the point that a lesson or two simply playing cards will be a massive benefit to your learners in their understanding and enjoyment of probability. If your learners don't play cards and have never played cards, then in order to solve this problem, they'll need to be told that there are 4 suits in every pack. You've got hearts and diamonds, which are red, spades and clubs, which are black. And in every suit, the cards are numbered from an ace up to 10, and then you have a jack, queen, king. So 3 picture cards in each of the suits. I would certainly say that telling a learner these facts about cards is far less fun than simply playing cards. And the more you play cards, the more you begin to understand probability, because you begin to know which cards are likely to come up, and that helps you to win. And winning at cards is quite good fun. So when we're looking at comparing these probabilities, so we've already said we've got 2 suits that are red, and each suit has 13 cards. So that's 26 cards out of a possible 52. And we can simplify this to say that the probability of dealing a red card is 13 out of 26. The probability of dealing a picture card, since there are only 3 in each suit and there are 4 suits, that means there's 12 picture cards in a pack, so that's 12 out of 52. We can simplify this to 6/26. Now, although we can simplify this fraction further, it's easier when comparing probabilities to keep the fractions with the same denominator. So, by comparing these two fractions, by comparing these two probabilities, we can say that it is more than twice as likely to be a red card than a picture card, because 13/26 is more than twice as large as 6/26. It's important that learners understand that a probability question may not contain the word probability. So getting used to words like chance, odds, or likelihood is very important when dealing with probability. And as I said before, you can express probability as a fraction, as a decimal, as a percentage, or on a probability scale. And either of these methods, when faced with a probability question in an assessment, is perfectly acceptable, unless it states otherwise. Now we'll come on to mean, median, and mode, which are all ways to measure average. An easy way to remember how to calculate mean is to think of a mean person who doesn't like to share. Because to calculate mean, you need to add up all the data and divide or share by the total number of values. Remembering that 0 is included as a value. So if you have 0 in your data set, you do need to add that up and you do need to count that as one of your values. So we have an example here. Andy started up an online HIT class. Below are the numbers of attendees for his first 4 sessions. What is the mean number of attendees per session? So we're calculating the average number of attendees and we're using mean, which is the most commonly used method to calculate average. So the first thing we need to do is add all of the numbers together. That gives us 64. And then we divide by how many we've got in the list. So in this case, there were 4 numbers. 64 divided by 4 equals 16. So the mean for this set of numbers is 16. So Andy's average attendance, or mean attendance, was 16. This method works for numbers of any size and includes numbers with decimals. So it can be used for discrete data. It can also be used for continuous data that may have fractions or decimals. Another method of calculating average is to calculate the median value. This is less commonly used, but it is important that learners know how to calculate the median. So to find the median value of a data set, what you need to do is rearrange the data in order from smallest to largest, and the median value is the value in the middle. I remember it because median sounds a bit like middle. So in this example, Laura wants to know if she has an average height. So she collects the heights of 10 friends. She wants to know how her height compares to the median height. Laura is 167 centimeters tall, and the heights of her 10 friends are as below. So in order to calculate the median, it's the middle value, but the first thing we need to do is reorder from smallest to largest. We can't just say it was the middle value from the way that we collected the data. We have to put it in order first. So put them in order, and it goes like this. And we can see that the two middle values are 163 centimeters and 165 centimeters. So it's a little bit complicated because the middle value would actually come right in the middle of these. So what we need to do is add together 163 and 165, gives 328, divide that by 2, gives us 164 centimeters. So that's the middle. You may just be able to see that clearly, since 163 and 165, you've got 2 between them, it means that 164 is going to be the value in the middle of those two numbers. So by using median as a calculation for average, Laura is actually 3 centimetres taller than the median height, which is 164 centimetres. Mode is the most popular value. So mode is another method to calculate average, but it's less commonly used. To find the mode, you need to look for the value that appears the most in the data set. Many people remember it as mode. It sounds a bit like most. So if you look at the data set, we can quickly see that there is only one value that appears twice. All the other values only appear once. So the most popular value is 168 centimetres. So if we use this as a method of average, then we would actually state that Laura is 1 centimetre shorter than the average, using mode as our method of average. Okay, we'll look at range now. Range is often taught at the same time as mean, median, and mode, and it can cause confusion because range is not a method to calculate average. Range is a measure of spread. So range is the difference between the highest value and the lowest value in a set of numbers. So in this example, what is the range in ages of Jacob's family? So his family are 18, 45, 72, 21, 16, 43, and 1. So the highest value is 72, grandpa here, and the lowest value is 1, the little baby. So the range is 72, take away 1, which gives us 71. So the range of these values is 71. And again, when you're calculating range, you do need to remember that if there is a 0 in your set of numbers, then you need to take 0 from the highest. For instance, in this set of numbers, we can see 15 is the highest, 0 is the lowest. So 15 take away 0 is 15. So the range in this set of values is 15. So we'll just take a look at graphs and charts. There are lots of ways to collect and record discrete data and organize and represent mathematical information. We'll go through some of the most common. Discrete data is numerical information that has a specific value. So with discrete data, there are no fractions or decimals. For instance, here it would be how many cars of each color in a car park. You can't have half a car, so this data is discrete. And here, goals scored during the season. You can't have half a goal scored in a match. So this is discrete data. The opposite of discrete data is continuous data. Continuous data is data that can take any value within a range of values. For example, people's heights could be any value within the range of human heights, not just certain fixed heights. So this can include fractions and decimals. So here we have a tally chart. Tally charts can be used to record the different numbers of various categories very quickly before you then enter information into a table or a chart. So this one is for colours of cars in a car sales room. Tally charts use marks or tallies to indicate the numbers of data. So you always, when you're doing a tally, you use lines, and the most you have is 5. So it's shown with a strike through it. So that's like in this example here for purple cars. So you have 1, 2, 3, 4, 5 with the line through it, and then 1, 2. So 5 add 2, that represents 7. And up here, you've just got 1, 2, 3, 4. So there are 4 blue cars. A frequency table shows how many times discrete data value occurred. You can see that it's very similar to a tally chart, only in this table, rather than a tally representing the number, we'll have the actual number. So this example shows how many times a football team scored a specific number of goals in a match. We know this because the table has a title, and each column has a heading. telling us what the information in that column represents. We can then analyze the data from this table. So when we're analyzing data, we're just saying what we see from the chart. So we can see that in 15 of their matches, they scored 2 goals. This means that this would equal 30 goals in total. You can also state that they didn't score 4 goals in any of their matches. So the highest number of goals that they scored in any match was 3. But the most common number of goals scored was 2. If you were to multiply the frequency by the number of goals, that would give you the total number of goals they scored over the season. So 0 times 8 is 0, 6 times 1 is 6, 15 times 2 is 30, 5 times 3 is 15, 4 times 0 is 0. Add all of those together, and that would give you a total of 51 goals scored during that season. We'll take a look at some graphs now. So here we have a bar chart of the data from the tally chart before. On the bar chart, you can see that the scale on the y-axis goes up in divisions of 2. So it goes 0, 2, 4, 6, 8, 10. Whenever you are drawing a graph, you must always, the y-axis must always start at 0 and go up in even intervals. If information is entered into bar charts, it can be easier to spot trends and extract information. So we can see from this bar chart that the highest number of cars in the car park of any particular colour was green, and the smallest number was yellow. So the least popular colour of car was yellow. You can also display data in a line graph. Some line graphs may make comparisons between sets of similar discrete data. So in this example, a health and safety manager is looking at types of accidents to try to put measures in place to reduce the amount of workplace accidents. The information in the line graph compares 2 different types of accidents within the automotive industry. So we have slips and trips represented in blue and cuts and burns represented in orange. When presenting information in tables and charts, it's important to remember to include titles and to label both axes. So we have our title here, Comparisons of Workplace Accidents in the Catering Industry. Each of our axes is clearly labelled, number of accidents and the year. The year going along the bottom, each year is marked. And then our y-axis again goes up in equal intervals. This time each interval is 500. That allows us to compare the data and see quite clearly visually how the accidents have been over the course of those years. You can also use a scatter graph to represent data. So this scatter graph shows the spread of goals scored by a team in their matches. So from this scatter graph, we can see that the most common number of goals scored in any game is 2. And again, we have a title, we have each axis labeled, we have a key as well. So the dots mean frequency. Again, we have a key here. So we've got number of cars, and we have keys here, slips and trips, cuts and burns. So when creating a graph, always remember a title, both axes labeled, the y-axis goes up in even intervals, and always include a key as well. Information can also be represented in pie charts. So a pie chart shows the proportion of the data being displayed. This pie chart shows the proportions of book sales for each quarter during a year. Again, a pie chart must include a title and a key. So we have the title and then we have a key. Pie charts are very useful ways to display data because they give a clear visual representation of information. To create a pie chart, it's important to remember that a circle has 360 degrees. So if we were going to deconstruct this pie chart to answer this question, the total number of books sold was 120. So all of this represents 120 books. how many books were sold in the 4 different periods. So we know that there are 360 degrees in a circle. If we divide 360 by 120, that gives us 3, which means that for every 3 degrees that you move around this circle, that represents 1 book. So we could say that in January to March, it was 198 degrees. 198 divided by 3 would be 66 books. From April to June, it was 90 degrees. 90 divided by 3 gives us 30 books. July to September, 36 degrees. 36 divided by 12 is 12 books. And then October to December, 36 degrees. 36 divided by 12 equals 12 books. So we can answer that particular question, but then also, if you were asked to analyze this data, or what strikes me particularly about this pie chart is the fact that I would have thought that more books were sold in October to December when people are buying Christmas presents, but actually that's the least, and it's actually January to March that the most books were sold. I'm not quite sure why that would be, but that's what the data tells us. So it's not what I would expect to see, but it's what the data is telling me. So to summarize, we've covered most of the content for handling data. However, please refer to the qualification specification for the full content. We've created resource bundles that accompany this session, including activity sheets, and you can access past exam questions on QualHub. So please use the activities at level 1 and 2 in the accompanying bundle for handling data to support this recording. If you have any questions about the content of this session, please email me, charmaine.phelps@ncfe.org.uk. Thank you so much for your time, and from all of us at NCFE, take care and stay safe.